So hello everyone. In this lecture we will see a Turing machine which will act as a copier. Okay, that means a Turing machine will take a unary number, okay, and make a copy of it. That is it will act as a copy machine. I will explain you with example, you will understand. So unary means for any number you will take one symbol for representing it, right? So here, so in this example we are going to take two ones, okay, as an input, and these are all blanks, right? And in the output there will be a four ones, means you will make a copy of these two ones, and in the output there would be four ones. Okay, so this would be the result. So you will give two ones as an unary notation, and in output there should be a copy of it. That means two ones copy would be four ones, right? So here I had written everything. Whenever you get an input of two ones, then at output Turing machine will make a copy of these two ones, right? Copy of these two ones. So total four ones will be there at the output, and this is unary notation. Okay, remember this. Okay, so let's see how can you come up with a logic to do this task. Okay, to do this task in Turing machine. So let's see, in this, for building a logic, I'm taking an example of three ones. Okay, so in the output, this is for input, I'm taking a three ones, and in the output there would be how much? Six ones would be there, right? So I will start from this left hand side. Okay, whenever I see one, I will make it x. Whatever one I'm seeing now, first I make it x. Then again I will move in right direction. Again I see one, I will make it x. Again I will move in right direction. Okay, but if I see one, I will make it x. Okay, then suddenly I will hit the blank. Then I will turn left. I will turn left, and I move in left direction, and unless and until I find the first x. And whenever I find the first x, again I will make it 1. Again I will make it 1. Okay, why we are making it x before? Because so that I can remember that how many ones I'd seen, so that Turing machine can remember how many ones I'd seen. Then after that I will start doing the copy thing. So whenever you hit the blank, turn left, unless and move in turn left and move in left direction unless and until you find the first x. And whenever you find the first x, make it 1. Then again turn right. After that turn right, and whenever you find the blank in right direction, make that blank 1. Getting the logic? Make that blank 1. Again after that turn left. Okay, turn left, crossing all the ones, and unless and until you find the first x. Unless and until you find the first x. So this is the first x, make it 1. Okay, then after that turn right. After that turn right, crossing all the ones, unless and until you find the first blank. Okay, whenever you hit the first blank, make it 1. Okay, then after that turn left. After that turn left, crossing all the ones, unless and until you find the first x. Whenever you find the first x, make it 1. Okay, then after that turn right. Turn right, crossing all the ones, unless and until you hit the first blank. Whenever you hit the first blank, make it 1. Okay, then after turn left, crossing all the ones, and whenever you hit the blank, okay, stop here. Whenever you hit the blank, you can stop here. That's it. So this is how the copy function will work. So at the end of this logic, you will find 6 ones in the tape, inside the Turing machine tape. Okay, so for this logic we have to build a Turing machine now. Okay, hope you understood. So how can you build a Turing machine? The first thing is, you will start from here. Okay, this is left, this is right. You will start from left hand side. Whenever you see 1, what you will do? You will make it all x. Okay, whatever one we are seeing here, we will make all of them x. Okay, so whenever you see 1, make it x and keep on moving in right direction. Keep on moving in right direction, right? Now after that, so you will make all this as x, right? Make all this 1 as x. So this loop will make all this as for x, and suddenly you will hit the blank. Now what you will do, whenever you hit the blank, make it blank and move in left direction. Move in left direction. Now you are in state Q1. And you have to move in left direction unless until you hit the first blank, and whenever first x. So whenever you hit the x, what you have to do it, you have to make it 1. So whenever you hit the x, again you make it 1. So for that, one more transition is there. So whenever you hit the x, make it 1 and move in right direction, right? Now you are in state Q2. Then after that, you will move in right direction. So you will move in right direction unless until you hit the first blank. So whenever you hit the first blank, again you have to make it 1. So this thing is continue, right? You are going to and frog. Okay, first you will go to x, make it 1, then go to blank, make it 1. So this is like a kind of loop. So after this x, again you have to, so that's why I'm making this loop. After that, you will see blank, make it 1 and move in which direction? Left direction. So this thing will be repeated again and again. You will go here, see the x, make it 1, again you will come to the blank and make it 1. That's why this loop is given. Okay, you when you solve it now, you will understand. Okay, now you come here. Okay, then now you made this blank as 1 and moving in left direction, you have to cross all the ones in between. So you are at making blank, you have reached at Q1, and here itself you have to cross all the ones, whatever one you see in the middle, you will cross it. So make that 1, whenever you see the 1, make it as 1 and move in left direction. Okay, so you will cross all this 1, and whenever it suddenly hit the x again, you will make it 1. So this loop, this transition will activate. So this configuration is defined. So whenever you see x, you will make it 1 and move in right direction. Again you will make it 1 and move in right direction. So while moving in right direction, you have to cross all the ones in between. So here also you have to mention that. So whenever you see 1, make it as 1 and move in right direction. In right direction. Okay, so here also when you're moving in right direction, whatever one you see, you have to make it 1, and suddenly you will hit the blank. So whenever you hit the blank, you are at Q2 state. So whenever you hit the blank, you make it 1. So here for that configuration already mentioned, and move in left direction. So you are moving in left direction. Then you will cross, while moving in left direction, you will cross all the ones. So for that we had mentioned the configuration. Whenever you see the 1, make it an 1 and move in left direction. Keep on moving in left direction unless until you hit the x. Whenever you hit the x, see, for that transition is mentioned. So that transition is make it 1 and move in right direction, crossing all the ones. So you have to cross all the ones when you're moving in right direction. So see, for that this configuration is mentioned. Whenever you see the 1, make it 1 and move in right direction. So you will keep on moving in right direction unless and until you hit the blank. So whenever you hit the blank, for that this configuration mentioned, blank, it will make 1 and move in left direction. And you will keep on moving in left direction, crossing all the ones. Okay, now you are in Q1 state. you'll keep on moving in right direction and suddenly you will hit the blank. Now when you hit the blank, for that no configuration mentioned, and you know that you had seen all the string inside the Turing machine tape, so now you can go and halt, you can stop, right? So for that you mention the configuration. So whenever you see the blank, make it as blank, and either you move in left or right direction, doesn't matter, it's better move in right direction, okay, and just halt. So in Q3 it will halt, right? I think this is your Turing machine. See, there are many application of this copy functions, okay. Whenever a Turing machine act as a copier, this particular function can be used for in arithmetic operation like multiplication. So multiplication make a use of this copy functions. Means this, when Turing machine act as a copy function, a copy machine, it can also mimic the multiplication operation in arithmetic operation, right? So for that we are make use of the concept of this copy function. So this is one of the application of this copy machine. You can use a multiplication. You can take two inputs and perform a multiplication.